Let's talk about the two lines can exist in a 2D plane. Then there are only three possibilities. The first one, the line L2 and the line L1 overlap each other. And the second would be when the two lines L2 and L1 intersect each other. And the third one, when the two lines L2 and L1 is neither intersecting or nor overlapping. It means these two lines are parallel. Now we talk about the shortest distance between these three cases. In the first case, the shortest distance between the two lines L1 and L2 is 0. And as same in the second case, when the two lines intersect each other, the distance between these two lines L1 and L2 is 0 because there is an intersection point. And in the third case, the distance between these two lines is not 0. And we can say if we take a point on a line L2 and draw a perpendicular on L1, and we can say if we take a point on L1 and draw a perpendicular on L2, then this distance is called the distance between these two lines. Now we talk about the lines in 3D plane. In the first case, the lines are overlapping. In the second case, intersecting. In the third case, parallel. And there are another case, fourth case, when the lines are not overlapping, not intersecting, and not parallel. Then how can we locate or visualize these lines when the lines are not overlapping nor intersecting and not parallel? So let's see this scenario in the 3D plane. So if we take a cube in a 3D plane and whose a corner is at a origin, let's suppose the red line indicate the x-axis and the blue line indicate the z-axis and green line indicate the y-axis. Then this cube is in the 3D plane. So let's see, if we take a line on our top face of this cube and we take the another line on the side face. So if we take a purple line on the side face and a green line on the upper face, then by removing the cube, if we remove this cube, then you can see from the 360-degree angle that if we remove this cube, then the lines which is in red, purple color and yellow color is neither overlapping nor intersecting and not parallel, because if we extend these lines, then they never intersect, not parallel and not overlapping. So if we see this in a plane, then we can say the yellow line is always perpendicular to the plane and act as a point, yellow point. So if we extend this line, then the extended line is always perpendicular to the plane and it never overlap a purple line, never overlap purple line as well as intersecting and parallel. So the fourth case is called the skew lines, means when the two lines are neither overlapping nor intersecting and nor parallel, then the lines are called skew lines. And there are so many distances between these two lines, because if we join any 2 points on the line which is perpendicular is called the shortest distance. So let's see, the equation of these lines goes through a given point A vector. As previously we know that the equation of the line passing through the point and parallel to the another vector. Okay. So if we take A vector is a vector which represent a line passing through the point A, and the B vector is a vector which is parallel to the equation of the line. So the equation of a line is represented as r vector is equal to a vector plus lambda times b vector, or where lambda is a scalar quantity which represents the equation of a line which is parallel to b vector. If we take these two lines, yellow lines and purple line, then the shortest distance between these two lines is considered as a projection of a vector which can be obtained by joining the 2 points a1 and a2. So the equation of these two lines are r vector equals to a vector plus lambda b vector, which is represented for the yellow line, and for the purple line the equation of the line is r vector is equal to a2 vector plus mu b2 vector. If we take the 2 points a1 and a2 and join, then we get the orange line, as you can see in the video, and we can say the shortest distance between two lines is the projection of the yellow line on a line which is perpendicular to both yellow line and purple line, which is indicated by the pink line. Means अगर हम इस ऑरेंज लाइन का प्रोजेक्शन फाइंड कर लेते हैं इस पिंक लाइन के ऊपर, और पिंक लाइन इन दोनों लाइंस येलो लाइंस और पर्पल लाइंस के परपेंडिकुलर है, तो वो जो प्रोजेक्शन होगा वो बोला जाएगा इन दोनों लाइंस के बीच की शॉर्टेस्ट डिस्टेंस. नाउ हाउ कैन वी फाइंड the projection of orange line on the pink line? So the distance d, the shortest distance d between these two lines is o vector magnitude into cos theta. It is the distance between the shortest distance between these two skew lines, but we know that cos theta is equal to p vector dot o vector upon p vector magnitude dot o vector magnitude and whole modulus. This is the formula to find the angle between these two lines, where theta represents the angle between the p vector and o vector, where o vector is the vector obtained by joining the 2 points a1 and a2, and p vector is the vector which is perpendicular to both yellow and purple line. So the a vector is equals to a2 minus a1 vector, and p vector is equals to d into n cap, where d is the distance between these two lines yellow and purple, and n cap is the unit vector of the perpendicular between the two yellow and purple lines. So cos theta is equal to d dot n cap dot a2 minus a1 upon d into o vector modulus. So d is cancelled by this d, and cos theta is equal to a2 minus a1 dot n cap upon o vector magnitude, and we can write this like d is equal to o vector magnitude dot cos theta, because if we multiply o vector to cos theta, then in the first case initially we see that it is equal to d. So now d is equal to a2 minus a1 vector dot n cap whole magnitude. Now the cross product of b1 and b2 gives the vector p vector, because b1 cross b2 means we have to find the vector which is perpendicular to both b1 and b2, which is indicated by the p vector. So according to the formula, b1 cross b2 is equal to b1 cross b2 magnitude n cap, and n cap is equal to b1 vector cross b2 vector upon b1 vector cross b2 vector whole magnitude. Now we can say that d is equal to